Hello everyone, so this is the demonstrate about how to set up AM32 development. So this is our Windows ESC development board. I have connected to the power supply and the signal pin is connected to a general Betafly flight controller with the latest Betafly firmware. So this is the ST lane already connected with the 6P pixel standard cable, and this is the USB to CAN adapter. This video will not use this CAN control yet, but I am happy to say this board AM32 is supporting the John CAN protocol. So let's get it started. At first, I suggest you have the STM32Q programmer installed, so you can easily to check the wiring connection everything is okay. So now I power on the development board. So you can see the ST link here. You click connect. We can see the flash data here. So I will do a full tree erase, and we start from 0 now. Disconnect. So first we need to install the VS Code and have this Cortex debug plugin installed, and we need to download the AM32 bootloader. The details you can find in our website here. So we need to install the ARM SDK first. In the terminal, we need to run make ARM SDK install. This will download the SDK. This will take a while, so I will skip this part. So first we need to know our bootloader target is defined by the NCU tape and the signal pin. So our ESC development board is L4 and the signal pin is PA2. You can check these details in our schematic here with the signal pin and the NCU model here. So we will make this target in the bootloader. Okay, now the build is success. We try to run it. So now the program is run, so we can pause to check if it stopped in your source code somewhere. So now since it's fun, now we open the AM32 online configure website. So we select the Betafly here. Now we try to connect. Can read. So the bootloader, it won't boot to the main firmware with the empty settings. So we can send the default settings here. Okay. Now, first thing we need to know, the AM32 is different from the BR32. It relies on the motor KV value. So we need to set the model kV first. The development board is 4300 kV, so we set the right value here, and you can check other parameters here, motor pulse and frequency. You can reverse the direction by this checkbox. So now we just change the model kV here. So we save. Now the bootloader have the EEP data now. So we close it. Now we back to our bootloader project. So we close the debugger here. Now we go to our main firmware. In the main firmware, the target information is in the target head file. So we need to know our target name here. The DV board target name is Windows L4 31. So we make this target. So it's compiling here. So now the bootloader have the SDK environment installed, and the main firmware still have the same process. You need to do the same and install the SDK in your repo. And this auto install script is also work in Mac OS and Linux based and Windows also. In Windows, you need to install the Make application if you don't have it. So now we try to run the main firmware. It's the same. So we can hear the motor beep. So it means it runs up. If it does not, you can make a pause if it can stop in the source code somewhere. So we can see it stop in this line of code. So we continue. So for debugging, we can use a lot of features here. If we want to monitor a global variable with lead watch, it will update. By default is 4 Hz. So we enter the variable name here. So our battery power supply is 16.8 volts. So we can get the correct battery voltage here. So you can add any variable here in your case, and you can view the register value here, but you have to pause it first. You can view the ADC register, the timer, ultra here. So that's the basic runs up the firmware. So now as you can see, the onboard WS 2812, the LED is not working here. So I will show you a simple PR so that can make the LED works. So I have already finished the code, so I will change to my branch. So I will give a reset so you can see the code change more clear. So in the repo here, you can see I have added the LED head file here and the C source code here, paint it. So also the peripheral, I painted here. So I have called the in function here. So I cannot set a breakpoint yet because the ELF file is not updated. So now I rebuild my target. So the build is success. You better pause first, and in this GDB section, type load command. Okay, now we try to reload. We hit the song here. So you can see it. The first is red and then turn green. So it worked like the code. So we set a breakpoint here in the peripheral. We set a breakpoint in the int function. Reload it, so we can see the breakpoint is set in here. So we can join into the function. We just add here. So we set the paint mode to output. We can find these LED functions. First, we send the LED RGB to red, and after we getting the signals, send to green. So we restart. In here, skip and set to red. Okay, it works. And now we join this breakpoint. We set to green. So the motor bits means bits like happy song. So it's getting the signal from the BL Heli. So I will show you how to set up a basic control. I've opened the Betafly configure, so I select the Betafly here. So in the motors, I have already set to the D-Shock 300 protocol and set the bi-direction D-Shock, so you can view the RPM and error rate, temperature here. So now you should be careful with if the motor spin will hit anything. So now it's clear here. So this is the risk confirm. Now you get the temperature here. Now you can see it's spinning. Disconnect. Now we can try to connect back to the bootloader again, but now I will close the debug session here. Go back to the configure. select the butterfly controller and read. Oh, we need a power cycle after okay, we get the correct information here. So we click the reverse here and save. Now we disconnect and go back to the butterfly. So now the motor is spinning in another direction. So now we have shown how to connect to the online configure and also how to spin it in the butterfly. And there's other protocol options you can see with Peterband and different DSOP protocol here. You can disable the bidirectional DSOP if you want. You can set the UTAP to add a ESC here if you want to use the TS pin from the ESC to connect to the butterfly UTAP port. You can find here. So I will also want to show you how to configure the melody. So in the escconfigure.com we have the melody here. You can hear the BlueJ melody. So we copy the RTTL string and connect, read. In the tune setup, we input the melody here and save it. Now we power cycle it. You can hear the melody from the AM32 ESC. So that's all. Thanks for watching. If you don't know this board yet, you can check it in our website. So goodbye.